Hello, my name is Rick Sparaccio. I am CEO and General Operations Manager for First Green Solutions, and we also have First Green Solutions Blonde. At this time, we'd like to present our PowerPoint presentation, which is prepared to give you an overview of the USIS technology. First Green Solutions was formulated in Hawaii and is a organization that it focuses on energy efficiency first. We operate and service commercial utility companies, water districts, manufacturing, hotels, restaurants, grocery stores, hospitals, schools, processing plants, farms, and orchards. We also work with the residential client and those that are considering solar. This is specifically engineered to save you money. We lower the true kilowatt demand, we lower your kilowatt hours, we correct your power factor, reduce the motor wear and maintenance, extending the motor life with less downtime. We increase the lighting ballast and lamp life. As a result of these two last items, for example, if you were needing to replace your motors every 10 years, then the extended motor life would go to, say, 12 years or 13 years. If you're replacing your lamps every 4 years, then you can basically extend that lamp replacement to 5 years. We protect against normal surges, spikes, and lightning strikes. So those facilities that have a lot of computers or electronic equipment are all protected by our technology. We reduce the total current content, including harmonics, and improve on all your overall system performance. We also reduce motor and ballast fixture temperature by an average of 10 degrees. We are also the only technology that is 100% compatible with variable frequency drives. This represents your meter here, this M. And as power comes through your meter, a typical electrical sine wave would be what is preferred. However, as motors turn on and off and loads increase throughout your business or home, then the phenomenon occurs here, which is called surges, spikes, and another phenomenon occurs which is called phase lag. This is when your power that you're utilizing exceeds what the utility company can't keep up with. What the USIS technology does is it captures these surges and spikes that would normally be wasted energy. This is normally taken to the motor and burned off as wasted heat. We capture that energy, convert it to usable power, and we inject it into the adjacent phase. The schematics for the system have been patented since 1992 and were invented by previous rocket scientists that worked for NASA. This technology allows the USIS system to reduce energy costs significantly and balance loads and reduce harmonics, all with a technology known as dual choke magnetic shunt technology. This technology here takes the energy and wraps it around this, from this phase, wrapping it around this coil. This is a solid core, iron core within the USIS technology. It is then wrapped outside of the core and passed back underneath the core of the adjacent phase. By doing this, this energy is being picked up, captured with the chokes, and then reinserted into the adjacent phase. So When we complete the installation, A phase energy is captured and shunted back into B. B is captured, shunted into C, and C is captured and shunted back into A. This allows us to also balance your imbalanced loads on your amperage. Previously, the utility company would be supplying you with power, and there would always be that wasted energy that's burned off as heat. When the usage system is turned on, the usage system takes that wasted energy and gives it back to the customer as usable energy, and therefore you draw less from the utility company. Performance of the system provides low voltage protection, industrial quality protection from external surges spikes for your entire facility, including lightning strike protection, which are self-sacrificing components within the unit. The usage technology generates electricity from the wasted heat energy. It's UL, CSA, and government approved. It's actually in the GSA catalog. It's maintenance free, 15 to 20 years expected life under normal conditions. It's installed in parallel to the load in the building, so we have no negative effects. The system can be completely turned on and turned off without affecting your facility's power. We have dynamic performance, which is constantly correcting your power quality. Modular in that we can add additional units as your business grows, or move units from one location to the other as your loads change from one location to the other. We have certified green technology, which conserves our precious resources and has been listed in many green technology catalogs. This is a resonance-free passive technology which allows us to be 100% compatible with all variable frequency drives and electronic motor controls. We have a utility patent, which means that in order to achieve the patent, the technology had to be proven to actually produce the power that it was claiming they could reduce. And these units are all made in the USA. Some of the clientele for the usage technology include the White House, which was installed in 1996, U.S. Postal Service, Corps of Engineers, Marine Corps, Naval Academy, most of the town of Waterford, Connecticut, Boston College, and the list goes on. Some of our newer installations are with Waikiki Ranch in Hawaii, Star Kiss Tuna in American Samoa, and the Marriott Resort here in Guam. When we consider combining the usage technology with solar, then the usage system is installed, and those that are planning on their solar system can now reduce the amount of solar panels needed. By combining the savings from the uses and the savings from the solar panel, we create the optimal energy saving technology. We also are protecting the uses. Units are also protecting the inverter and extending the lifespan of the inverter. Inverters are the weakest link in any solar system panel because the uses units are protecting the inverter from the surges and spikes that normally would deteriorate the inverter prematurely. So the inverters usually will last half the lifespan of the solar panels and have to be replaced. With the usage technology, we can extend that lifespan by about 25%. We have models for every application. We have recreational models, residential models, commercial and industrial models. We typically will come out, we'll do an energy audit of the facility, and then we will determine in combination with your power bills what overall cost would be for the uses installation and your return on investment and savings. This is an installation where we are installed 10 usage units on the wall at a printing facility. This facility only operates about 12 hours a day, and so as a result of that, the usage units are run through a contactor cabinet. The contactors are energized and de-energized by this time clock, and all of the power passes through the panel. Each of the usage units has a breaker within the panel, its own breaker, and then it feeds the entire bus of the panel, and the panel then is fed back with all the energy into the main service. This installation is generating 29,000 watts of power at 480 volts three-phase and 31,000 joules of protection, resulting in a 17% annual savings for our client with a less than 2-year return on investment. We have a testimonial letter to that effect on our website as Diversified Printing. The installation process is we basically do the power assessment, we create the proposal, complete the installation, and then upon completion of installation we'll do a system verification. This is a way for us to take timed interval data recordings with the usage units turned off and on at precise intervals. In this case, this is the Marriott Hotel. We're turning the usage units on and off in precise 5-minute intervals. So this is their power consumption up at this level when the usage units are off, and when the usage units come on, their consumption's down here. This graph is for kW, which is measured by the utility company as power consumed. We're going from 876,000 average down to 846,000, which is roughly a 30,000 savings. On the apparent power, which is the kVA, which is also measured by the utility meter, we're going from the 965,000 range down to the 800,000 range, 850,000. So this represents 105,000 kVA reduction. Current is measured amperage, and right now they're looking at averaging 1,200 amps, dropping down to the 1,040 amps, which is approximately 160 amp reduction. And that is on a per phase basis. Then we have the reactive power, which is what we capture the most of, which is your wasted energy that's being burned off as heat. We capture that reactive power and convert it into usable energy. In this case, we're going from 390,000 to 90,000, or capturing 300,000 volt amps of reactive power. True power factor is a measurement of how efficient the power is within the facility, and in this case we're going from a 0.91 power factor to a 0.995 power factor. The voltage always increases slightly when our usage system is turned on. This is beneficial to those motors that are a distance away from the service. In summation, we're basically summarizing for the client the findings that we have on the recordings. And the recordings and the summation are all part of our verification process, which each client receives after we install the usage technology. At this point, we're summarizing that 30,000 watts, 110,000 volt amps, 150 amps, 305,000 VAR, and 6 volts with a +8 increase in the power factor. The utility company measures their kWh that they bill each client by combining roughly the amount of kilowatts divided by 2 plus the amount of kVA divided by 2. So with these savings end up being 70,000, which equals 70 kWh for the 16 units. Doing all the math for the various amounts of reduction that's happening from each unit by adding 2 more units, because we had an additional amount of kVAR that we could capture, and by subtracting the chiller that is turned off at night, we end up coming up with 48,000 kWh saved per month at 28 cents a kilowatt hour. This equals $13,537 times 12 months of the year, ends up being $162,000 for that particular service. They have 3 services. The other 2 services, similar readings were taken and summations were performed. T2 is 19,380 kilowatts saved, and T3 is 30,398 kilowatt hours saved. Total 98,126 kilowatt hours saved times 28 cents a kilowatt hour, and multiplied times 12 months ends up being roughly $330,000 per year savings for the Marriott. This ended up being a significant more savings than we had projected, and reducing their overall ROI to less than 1 year. This has also been confirmed by the Marriott and the power bills that they've been receiving since the installation went in September. We also have a testimonial letter from the Marriott itself confirming these figures. We have Kamehameha School, which we completed in January of 2012. These are the results from that installation, where we have 3 usage units on one of their chillers, and we have the usage units on and off, and we're showing the variations in the performance of the units for kW reduction. This is the kVA reduction, current reduction, reactive power, power factor is going from 0.81 to 0.99 or 97. Chiller number 3's voltage is increasing as the units reduce the current, the voltage is increased. The summation on this particular installation was also exceeding of the proposed amount we projected would be saved by those 3 usage units. We had projected the savings would be $531 per month, and it ends up that from the recordings and the power bills that they're receiving, we are saving them $1,500 a month, almost double what we had projected. They will also be saving a additional demand savings, which Helco, the power company there in Hawaii, provides for them after 1 year of reduced demand. Starkist Logistics, these are the results from their graphs. 80,000 watts reduction, 180,000 volt amps, 200 amps of power reduced, 330 bar, and this is from 15 units. So their performance is even greater than the 16 units recordings that we did at Marriott. So there's significantly more savings based on the fact that the energy in the island of American Samoa is dirtier than here in Guam, if you can believe that. Waikea Ranch, which is another installation we installed in Hawaii, is a very large deep well. This is a 200 horsepower deep well which is supplying the entire ranch with power. We have this happening right now where we have the results from the recording showing 15.35 kWh reduction. The significance of this particular installation is they wanted to know how much they were saving on the gallons that they were pumping. So as a result of the USES installation and the power bills that we were able to acquire, and they also keep graphs on charts on how long the motors are pumping. The overall gallons pumped were 2,255,000 before the USES units went in this month billing period, and they used 58,000 kilowatt hours. The following 2 months after the USES units went in, 1,977,000 gallons were pumped in this month at 51,000 kilowatt hours, and 2,289,000 gallons were pumped at 55,000 kilowatt hours. This resulted in the amount of kilowatt hours being reduced for the amount of gallons pumped. So in this case, they were pumping 38.5 gallons for every kilowatt they were using, and we were able to increase that to 41.5 and 41.59 gallons for every kilowatt that was being used, and that represents an 8% increase in performance in the pumps. And that's our PowerPoint presentation.